Dear students, in today's lecture we are going to discuss about how to read a piping and instrumentation diagram, that is the P&ID. In the previous lectures, you are familiar with the various symbols that will be used in constructing the P&ID diagrams. Now, in this lecture, I will show you a few P&ID diagrams and how to interpret the information contained in those diagrams will be discussed in this lecture. So this is the first example I am going to show you. This is the P&ID diagram of a pressurized vessel. Whenever you are reading the P&ID diagram, you should look for certain information at the bottom corners. So that bottom corners will indicate the title box and when it is created, and if there are any revisions in the P&ID, all those information will be contained in the bottommost uh, area of the P&ID diagram. So if you look at this example, this is the P&ID of a pressurized vessel. So all these major equipments needs to be numbered so that it is easily identifiable, and there will be a legend to interpret all these identification marks. So we also should look at the legends if you are not clear about any of the symbols uh, in the P&ID. So it is a very good practice to read the P&ID from the left to right and to look at the major flow lines of the material. So here this pressurized vessel is having a major flow line with a temperature indicator Ti, and the pressure is indicated using this symbol Pi, and there is a level transmitter because the pressurized vessel is going to store some uh, fluid or gas. So we have to look at the level of the fluid inside this pressurized vessel. So for that we require a level transmitter. There should be a feedback loop to regulate this level indicating controllers. So whenever this pressure vessel is released to drain the fluid or to fill the vessel, we have to look at this control loop for uh, measuring the level of the fluid inside this pressure vessel. So this control loop is indicated by this LIC, that is level indicating controller. The level indicating controller is going to get the signals from the level transmitter, and the pressure of this pressurized vessel is indicated in this PI. So here I already told you about the various lines that will be used in the gauges and the measuring devices. Here if you see that if you have only a single circle without any lines, then that is the instrument is present on the field, that is also known as field mounted instrument. Now if you see that in the circle you have a solid line, that means it is mounted on the main panel. Then if you have a line that is a single line or dotted or dashed line, that means you cannot directly access that measuring instrument. So it is mounted on a main panel if it is indicated by the single solid line, or if it is indicated by a dashed line. That is, all those measuring instruments are controlled remotely. Then in the case of two solid lines or two uh, dotted lines, then it means those measuring instruments are inaccessible, or it will not be invisible because they are mounted on a control panel. So also here the same legend is given there. If you have a circle with no line, that means the measuring instrument is present in the field. If it is with a solid line, then that measuring instrument is present in the control room. And if it is having a dashed line, then that means the measuring instrument is not directly accessible and it is provided with the automatic control. So if you look at this pressurized vessel, you have the level indicators, pressure indicators, temperature indicators along with the various valves. This LAH will be the alarm for low level, and LAL will be the alarm for the high level, that is corresponding to this pressure vessel. And you have the legend that indicates the material that is flowing into this pressure vessel, that is the wet flue gas, which is indicated in line 1. Then in line 2, the material flowing is air. It is flowing at the process conditions of 600 Kelvin and 288 Kelvin, and the pressure is 1 bar. The corresponding flow rate of the wet flue gas and the air is given in this box. So this is the first example of a P&ID diagram, a very simplified version of the pressure vessel P&ID diagram, which contains some relevant information about interpreting the various symbols. So you can also look at the various symbols provided in the previous lectures and try to understand a few other symbols that are not explained to you. So I leave it to you as an exercise so that it is interesting for you to comprehend the various P&IDs. So what is the meaning of this dotted line? It represents an electrical signal to the actuator. So next example we move on is the instrumentation of a petroleum refinery, where you have a crude oil feed tank which is flowing through an orifice meter. The orifice meter is the flow transmitting device, and there is a control loop to regulate the flow with the flow valve. This is the flow valve 1, then flow controller 1, and the flow transmitter 1. So all these three equipments will form the control loop to regulate the fluid flow into this heater. So here the solid line will represent the pipeline, and the major equipments are given by this instrument symbols. And if you look at the instrumentation for this preheater, we have 4 temperature transmitters, that is the TT01, TT02, TT03 and TT04. So all these 4 instrumentations will help to transmit the value of temperature when the crude oil is preheated and sent into this distillation column. And if you see that the control loop is given by the TT02, the corresponding temperature controller will be TC02, and input output signals transmitting will be done by this input output 02. Then it's connected to this control valve, and there is a PT, that is a pressure transmitter. If you have a solid line, what does it indicate? It is mounted on the control room. And this is one section of a P&ID which shows the cooling tower, a gate valve, and the major process flow indicated by this solid arrows lines, and a few symbols for the equipments. As per the P&ID symbols, it is created. So next, if we slightly move uh, to the next part of the same process flow sheet, we can see that the cooling tower is labeled as CT105, and you have a pump which is labeled as P12, then a valve which is named as V2 and V3, and so on. So all these are your code and symbols as highlighted in this pink color. It is an actuator. The actuator can be pneumatic or hydraulic or solenoid based. This is the control loop as indicated by FC. F stands for the flow and C stands for the controller. And FV stands for the flow and V stands for the valve. This is the code and the symbol corresponding to this control loop, which comprises of a controller, actuator, and sensors. So this is the P&ID example 2, which contains some information about the crude oil distillation in a refinery. Next, if we want to look at the flow directions, you can see the arrowheads. The arrowheads actually represent the flow directions. So here it is labeled, all the control valves, gate valves and everything is labeled, and there is a sampling point which indicates uh, by this box with the symbol SC. And if we want to continue this P&ID diagram, we need to uh, use some connectors. So the next section of the process will be represented in the next P&ID sheet. So to use this connectors, we have to uh, check for this sample point. So this sample point is actually connected here. So from this sample point reference, we need to search where the sample point is located, and we need to continue to read the P&ID from that notation. So if you want the next section to be uh, noted in the P&ID, then we need to use this connector symbols to represent this flow arrow where it is going to represent in the next flow sheet. Okay, so it is difficult to represent the entire process flow in a single sheet. So there will be P&ID sheets 1, 2, 3 and so on. So we need to look at these interconnection references and continue reading the P&ID from those references in the next sheet. So this is about the example 2 of the P&ID. Next, we look at slightly complex P&ID, a section of a P&ID. Here you can see that the valve informations are also given, and there is a 4-inch valve or 1-inch valve. All these details are actually given here. Or a 2-inch valve, how the connections are made in the field, and whether the indicators are also represented here. And this is the solid pipeline, which contains some information about the pipeline values, whether it is a 1-inch line or a 2-inch line and so on. And this instrumentation is about a storage tank, and it is giving you a much more detailed information. So I can leave it to you as an exercise to understand these legends. ZLO, what does this alphabets stand for? You can refer to any P&ID legend uh, notations and all those abbreviations, and based on that you can comprehend what is present in that boxes. So here it is a highly comprehensive information is given there. Here you can see that there is a reducer which is used to reduce the size of the pipeline from 2-inch to 1-inch and so on. You read the P&ID from the left direction to the right direction by following the main process flow arrows. After that, you look at the instrumentation corresponding to that particular line, and you identify the cluster of instruments for that particular control loop. So by that you can comprehend the necessary information related to that diagram. Next, we move on to the next section of this same P&ID, the continuation of that previous slide. So this is the storage tank. So in the storage tank, you can see a lot of information about the level indicators, transmitters, then valves, pressure regulating valves, and the location of the various nozzles are given as N1, N2, N3, N4, and so on. So here we have the nozzles N14 to N18. So the location of various nozzles are actually indicated. Then the level of the fluid which can be stored in the tank, that is also indicated. The corresponding level alarms can also be indicated by that LAL symbol, that is low alarm level and high alarm level. So the maximum fluid storage can be done up to a height of 8500 millimeters, and the lowest level for the storage tank will be 1000 millimeters as indicated by the legend in this storage tank. And also you can see that the information regarding the line size, that is indicated by the arrowheads and the legend corresponding to those arrowheads. You can See the various pressure transmitters, the mountings of the storage tank, that is given by M1 and M2. The size of the nozzle is also indicated as 6 inches or 24 inches and so on, 8-inch nozzle or 2-inch nozzle, and the size of the various mountings are also indicated by these legends as 24 inches of mounting. So this is about the storage tank, the instrumentation which is present along with this storage tank with all the necessary information is explained to you. Now continue this flow sheet with the tank gauging system. So here it is showing you the various instrument clusters of this tank gauging system. Here also I will leave it to you as an exercise to comprehend the various alphabets which are present in those instrument clusters. So you can refer to any P&ID legend and identify the various alphabets and what those alphabets will represent by looking at those legends. Next is the example of storage vessel P&ID. So here we are having a few additional instruments called the vortex breakers and a demister pad. This demister pad will be providing the uh, support to capture the liquid which is entrained in the vapor by coalescing the liquids into bigger bubbles so that they cannot escape along with the vapor. So the demister pads are necessary to prevent any loss of fluid by the vapors which are flowing out of those vessels. So here also you can see a very clear-cut instrumentation of the valves and the level controllers and the level transmitters along with the vortex breakers, those solid lines, how it represents the process flow, and the various types of valves that are used along with the symbols for the demister pad and vortex breakers. Next, we move on to the P&ID example of a benzene toluene separation column. So this is a distillation column where you have the separation of benzene and toluene. The tower is named as T101 and the corresponding other equipments are mentioned as the legends as E106, then P102A stands for the pump, then V104 stands for a storage device, and this E104 may stand for a heat exchanger. E106 is another heat exchanger. So here the information about the pipeline is given here. 2-inch schedule 40 and CS will stand for the carbon steel, that is the material of construction. So here in this process flow sheet we can see that the pipelines are of different sizes. One is a 2-inch line, a 4-inch line, and 12-inch line with different schedule numbers, and the entire process piping is based on the carbon steel because in all the pipelines we are seeing the symbol CS, so that stands for the carbon steel. And if you look at the various temperature level and pressure flow indicators and controllers, all those control loops are given in a particular section, and we need to cluster those by the numerals, and we should understand the presence of the control loops for the different sections of this process plant. So this is the P&ID example for the separation of benzene and toluene, and here also you can look at the various utility connections. So the legend actually says if you have one in the process line, then that is representing the passage of cooling water, and if you have 2 labeled as 2, then that means it is the cold water return. If it is labeled as 3, then that is representing the steam line, and if it is labeled as 4, then it is the condensate line, and if it is labeled as 5, 6 and so on, we can read the utility connections from this legend. So this is a P&ID diagram, example P&ID diagram for the separation of benzene and toluene. So I You can also practice reading the P&ID by looking at this diagram and understanding how the process flow is happening. The separation system of benzene and toluene is explained here. And these connectors are represented by this half moon kind of circle, and all these are connectors. So the connectors will be present in the next P&ID diagram. So we can continue this flow from this P&ID sheet 1 to P&ID sheet 2. So this is how you have to differentiate those connectors, and you have to understand the process flow based on these connectors, and where it is present in the second flow sheet or the subsequent flow sheet. So always remember, you should comprehend the information by using this legend and also the various numerical the symbols along with the alphabets, what it actually represents, which flow variable it represents, whether it is a temperature or flow or the pressure or the flow rate. Those needs to be properly identified by this alphabets. Next is an example of a P&ID diagram corresponding to an evaporative crystallizer. So this SC1 will stand for the crystallizer, and the SP1 stands for the evaporating arrangement with a downcomer. The legends of the pumps and the corresponding valves and the connector diagrams symbols are actually shown in this picture. You can have this flow sheet as a practice to understand the process flow of an evaporative crystallizer. So to remember or to recap how a P&ID diagram should be read, it is always read from the left to right, and the P&ID diagram should comprise of a legend. So if you have a legend to interpret the information, that needs to be kept side by side so as to comprehend the relevant information. Represent all the major equipments by the corresponding P&ID symbols, and the process flows are represented by the solid lines. Then the control loops are represented by the dashed lines. Then all these major equipments have a particular naming convention, and all the temperature transmitters, pressure transmitters have a certain naming convention. We have to follow the naming convention and give the corresponding legend, and we have to look at the various connectors in the process flow sheet and the P&ID diagram, because those connectors will represent the continuation of the P&ID to the next section. So we have to look at those connector symbols. We have to indicate the size of the line and the material of construction, and we can also have a table to represent the mass flow rates of the different lines, and we can also have the legend to indicate the utility connections uh, and the various valves and so on. Mostly the instrumentation is represented by the symbols and the major equipments. We may not have a legend for all those because all standard symbols only will be used, but only for the alphabets that might be used in the P&ID diagram, we can have the abbreviations of those alphabets. So we need to understand the information which is conveyed through those alphabets by reading those legends. So this is about how to read a P&ID diagram. You can practice reading this P&ID diagram of this evaporative crystallizer, and I leave it to you as an exercise so that you are familiar with understanding the various P&ID diagrams. Thank you.